Okay, thank you. Yes, as Wojciech told before, we have a couple of advancements in OpenRTX development. We have that, before the modulation part, Wojciech gave us important help in developing the Golay decoder, which now works. And as I told the last net, we chose to go for an arithmetic implementation of the Golay decoder to save basically flash space. So this implementation, and it works and is committed in the OpenRTX firmware. And now we are, with the help of Wojciech and Nicolas, developing the modulation part for the FSK stream. And in parallel, which is something which I'm trying to do, is developing the Viterbi decoder for the basically the decoding and of the incoming stream. And we hope to have on one side Viterbi and on the other side the real for FSK demodulation in short times, and I hope they will arrive more or less in parallel so that we can merge everything, implement the last small pieces which are not of great concern, and finally have M17 reception also in decoding on OpenRTX. And yeah, more or less updates are those. Other small updates are that I finished assembling another sound card and from Wojciech's design, which will be used here in Italy to do some experimentation and to set up probably a repeater in the next weeks, months, weeks, I hope weeks. And yeah, more or less situation from OpenRTX and Italian side of M17 is this one. So back to net control.
Okay, so this is KC1AWV Net Control. Unfortunately, it seems as though that you were dropping packets left and right there, and I wasn't able to copy 100% of what you said. Would you mind just giving us a quick overview of everything that you discussed, and we can probably try and capture it so we can write it down?
Okay. Sorry for that. It seems that I have some network problems. So just give me 1 minute so that I switch my phone from Wi-Fi to cellular network, and in the hope that we have hopefully 0 packets loss. Back in like 30 seconds. Okay. India Uniform 2 Kilo Whiskey Oscar back. Yeah, small and fast recap of what I told before, which arrived in pieces. We have Golay 2412 decoding, thanks to Wojciech, which helped in implementing the arithmetic decoding. Wojciech is giving us help in implementing the 4FSK demodulator for the processing of the incoming audio stream and to obtain M17 bit stream. In these days, I'm beginning to work on implementation of Viterbi decoder for processing of this stream, and I hope we will arrive at a conclusion in parallel of the modulator and Viterbi, so that at that point, when we have both of them, I hope they will arrive to completion in parallel. When we have both those pieces, it's just a matter of connecting those pieces together, plus the remaining parts of code which are not of significant concern. And at that point, we will effectively have M17 reception and decoding on OpenRTX and on handheld devices. And yes, more or less updates are those. And yeah, en passant, I just finished assembling another sound card of the model that was designed by Wojciech for his repeater, and we are planning to use that in an Italian repeater, M17 repeater, which we are going to set up hopefully in the next weeks. Updates are those, so back to net control.
Okay, Silvano, thank you very much for that. We were able to capture everything that you said this time without any packet loss. It was much smoother and clearer. So, let us go ahead and see, are there any questions or comments for anything that Silvano or Wojciech has given to the net today? Any questions or comments? This is KC1AWV.
Sierra Papa 5, Whiskey Papa, with a short question for Silvano.
A short question. I'm trying to picture that in my head. Is it physically short? No, I don't know. Wojciech, SP5WP, go ahead.
Okay, so this is the question. How do you want to test OpenRTX? How do you want to feed it with a baseband that we are going to synthesize, let's say? So generate a clean baseband and then maybe add some noise, some more noise, some less noise. So how do you want to check OpenRTX and how it behaves when presented with good or bad baseband signal?
Ooh, that's a good question. Good point. I think we have two ways to test the decoder implementation. First way is to use the Delta Bravo 9 Mike Alpha Tango module 17, which can be brought up and running with OpenRTX in a very short time, because it does not have a proprietary radio part for which we have to write drivers. So it's something we can bring up very quickly, and it gives us directly an audio interface in which we can inject signals, extract signal, inject signal plus noise, whatever. So I think that that will be a valuable platform for testing the decoder. Then, once we have something which is up and running reliably on module 17, I think we can switch to MD380 using MMDVM, using Pluto SDR, using whatever. And yeah, I think that's it. Other tests can be carried out from my point of view using the x86 implementation of NRTX Linux. Just take the baseband signal from a binary file and treat it as if it was it is coming from an ADC, basically. Back to net control.
Oh, that was back to me. Sorry about that. Okay, great. Thank you, guys. And a lot of interesting information being tossed around here. I do have one more check-in. I'm going to count this, even though it came in through YouTube. But we do have a person listening, Andy, 2 Echo 0 Romeo Echo Echo. He's listening in using the YouTube live stream. And I think we got a couple other people that are just sitting here listening in as well. So thank you for joining us and kind of following along with what's going on here. This is KC1AWV Net Control. Do we have any other check-ins? Any check-ins for the net? Please call now.
Okay, no checking, so I'm going to ask Silvano one more question.
Yeah, you can't do that. You can't just barge in whenever you want. Wojciech, go ahead with Silvano. KC1AWV Net Control.
Okie dokie. The question is, do we have to redesign our board with AX5043 to support AX5243 that we have? I mean, we possess it, we have it, you have it. So, is it a good idea to redesign the board for the other chip? So, what do you think?
I have to see, but if the design you found on GitHub is not suitable, maybe I think that let me think. I think that we can take that design and adapt it to our needs. I think is the fastest way. But I mean, I don't know at the moment because I haven't already compared the two designs. How much they are different. The one we have now and the one you found. So, well, we can adapt that design basically, but really, I have no clear idea yet about that. Back to next control.
SP5?
Yeah, I wanted to make sure I gave you a couple extra seconds. Go ahead.
Okay, for those that don't know what we are talking about, we are talking about our development board for AX5043 RF front end, which is a complete front end like a complete radio. So it's a transceiver basically, with the output power of about 20 milliwatts. And the purpose of this having that board is to check if the baseband generated with this RF IC can be used for M17 and vice versa. So if we took a baseband and fed it to the chip, we can get a valid RF signal out from it. As you probably know, there is a big problem in sourcing integrated circuits, not only for the RF parts, but practically anything from microcontrollers to anything. So we have ordered AX5043, which is not available right now, and we should get them in December. So that's a long time to wait. So we decided to maybe switch to AX5243, which is a slightly different chip in slightly different carrier. So it has a lower pin count and probably some lower power output, but more or less it's the same. And Silvano, I'm looking at the schematics for the AX5243 and our design. So it looks like the only difference is that they are using a low-pass filter after the SMA connector, and at pin 6, where is the PLL filter, they are using just one single capacitor, while we are using a capacitor and a resistor. So those are two differences between our designs. And the radio frequency matching circuit is the same. So I think we can use it, or maybe we should just take our schematic and drop in the AX5243 and then do some slight modifications to the PCB and just order it and check if it works. So that's my idea, to take the board, which we already have, the design, drop the new integrated circuit, and then just reroute some wires, and it should work right away with no modifications. Okay, back to net.
Okay. I don't know where I was going to go with this, but that's a lot of information to take in. I'm trying to run the stream and do net control at the same time, so I wish I had another set of hands to kind of, help me out with what's going on here. But all right, thank you, Wojciech and Silvano, for all that information and keeping us informed as to what's going on between the hardware and software side of implementing M17. I'm going to go ahead and pass it out for one more round of check-ins. If you are wishing to check into the net, please call now. KC1AWV Net Control. Okay, nothing heard at this time. I will go ahead and get ready to shut down the net in just a moment. Okay, this is KC1AWV-R control for the M17 Project Net. I apologize for that delay. Even though I'm on lunch, I'm still being asked to provide IT services. But with that, I'll go ahead and get ready to close down the net. I want to go ahead and thank you. Oh, goodness. I want to thank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 check-ins, 10 people that checked in. Thank you very much for checking in and participating in the net. Without your participation, there wouldn't be any net, and it would be kind of pointless to just sit here and talk into a radio. So, thank you for joining us today. I also want to thank the OpenRTX project for all the work that they do doing M17 implementations into software and hardware with us. It is definitely appreciated. I also do want to thank the Open Research Institute, who is our fiscal sponsor, and the ARDC, the Amateur Radio Digital Communications, what is that organization? I think it's an organization, ARDC, for providing us the grant money in order to do this stuff. I mean, without their help, M17 wouldn't exist. So I want to give a big thanks to those folks out there. With that, I'll go ahead and close out the net. And as soon as I get this, yeah, looks like everything's good. So this is KC1AWV. Steve, the net is now secure at, looks like 17:38 hours on the 29th of October, 2021. And the net is now secure. This is KC1AWV 73.